So the second type of motion is fixed axis rotation. So let's say we've got the wheel and it's spinning around that center point. Now, say this is A and this is B. The wheel is spinning around A. So if we look at a side view of it, we've got this axis of rotation going through the middle. So say that's B, that's A, its radius is R, and it's rotating. Counterclockwise rotation is considered positive. So we'll say that is theta dot. And theta dot is sometimes also represented as omega. Now, omega also happens to be a vector. So the omega vector goes like this for rotation in that direction. This is the right-hand rule. So thumb is the axis of rotation. That's the vector, and fingers point in the direction of rotation. So this is positive. My fingers curl counterclockwise, and my thumb points in the axis rotation. I hope this is not showing a mirror image for y'all. I'm using my right hand, so you can all use your right hands. So other direction, thumb points back, fingers curl clockwise, so that's a negative axis of rotation. The angle of rotation is theta, so the speed is theta dot, but a lot of times we just write that as omega. So you may have learned from physics V equals R omega. It's the same kind of thing here. Let's say it started right here, and now it's here. For this distance S, it is rotated by angle theta. Well, S equals R theta. Because if we go all the way around, we know that the circumference of the circle equals R times 2 pi. 2 pi radians in 1 revolution. So C equals 2 pi R, S equals R times theta. If theta is less than 2 pi, then the arc length is just S. Velocity B, we've learned from our polar formulas, equals R dot UR plus R theta dot U theta. But if it's fixed axis rotation, then R is not changing. So this 0 for fixed axis rotation. So then we get that VB equals R theta dot U theta, which is the same as V equals R omega if we write it as a scalar. But the direction is going to depend on this. So we can also say omega cross with the radius. We'll get the direction vector. Now, if we have this being X, this being Y, then here is going to be the K hat. So the Z points out of the page. If X goes to the right, Y goes up, Z goes out of the page. So omega is always going to be in that Z direction for this type of planar motion. Something spinning in a plane, omega is in Z. If it spins clockwise, omega is going to be negative Z. Now the acceleration here, we just again take the derivative of velocity. So for our polar formulas, we have R double dot minus R theta dot squared UR plus R theta double dot plus 2 R dot theta dot U theta. But for fixed axis rotation, R double dot is 0 because R isn't changing. r dot is 0. So then we just get AB equals r theta dot squared UR plus r theta double dot U theta, which if we write that as vectors, that's going to be equal to omega cross r plus alpha cross r. So this would be, this omega is the rotation of body AB, and the radius is B with respect to A. Now also up here for translation, we've got AB equals AA. They're moving at the same speed, they're accelerating at the same speed. Now here, this is the relative because we got a fixed axis rotation. So